Good morning, students. Today I am going to start Module 4 of Big Data Analytics, that is on decision trees. Decision trees are a simple way to guide one's path to a decision. And the decision may be simple, binary one, whether to approve a loan or not. This is the best example of a decision tree. So where we can take an example for deciding whether the bank loan is approved or not, or it may be a complex multi-valued decision as to what may be the diagnosis for a particular sickness. So we have come across a cancer decision making, so that cancer patient diagnosis can also can also be taken as an example for constructing a decision tree. So decision trees are hierarchically branched structures that help one to come to a decision on asking certain questions in a particular sequence. So decision trees are one of the most widely used technique for classification. Decision trees falls under classification. Fine. So this is a simple definition of a decision tree. So decision trees are a simple way to guide one's path to a decision. These are used for decision making purpose. Next, let us go to a decision tree problem. So imagine a conversation between a doctor and a patient. So if there is a doctor and a patient, so doctor will be probing several questions to determine the cause of the ailment. So the doctor would continuously ask few questions till he or she is able to arrive at a reasonable decision. If nothing seems to come to a conclusion, he or she might recommend some tests to generate more data and options. So human experts from past experience or data points, human experts learn from past experiences and data points. Similarly, a machine can be trained to learn from past data points and extract some knowledge or rules from it. Decision trees use machine learning algorithms to abstract knowledge from data. A decision tree would have a predictive accuracy based on how often it makes correct decisions. The more training data is provided, the more accurate its knowledge extraction will be, and thus it will make more accurate decisions. That is, the more the training data you give, the more accuracy we get. The more variables the tree can choose from, the greater is likely of the accuracy of a decision tree. In addition, a good decision tree should be also frugal, so that it takes the least number of questions and thus the least amount of effort to get the right decision. So here below we consider a training data and try to construct a decision tree. Meanwhile, if you would like to do parallelly, you can pause, you can take down this decision tree data set and then proceed with the construction of a decision tree. So here in the example we have outlook, temperature, humidity, windy and play, and the first row illustrates as sunny, hot, high. If the outlook is sunny, temperature is hot, humidity is high and windy is false, the decision made to play is no. Similarly, there are a set of rows which gives you a training set, data set. So this data you can note it down, and we would like to solve a decision problem for this. If the outlook states sunny, temperature hot, humidity normal, windy true, whether the decision made to play is yes or no. So the objective here is to predict the play decision given the atmospheric conditions out there. The decision is should the game be allowed or not. So to answer the question, one should look at the past experience. So the past experience is nothing but the data which is mentioned below, which you can note it down. And I would like to suggest all of you to do parallelly, step by step, so that you will be very much clear to construct a decision tree at the end. And this would also be an important question with respect to your exam point of view also. Okay, fine. See, one could look up the database of the past decisions to find the answer and try to come to an answer. There are 14 instances which are mentioned here. You can make a note. Now let us start with decision tree construction. Decision tree is a hierarchically branched structure, as all of us know. We should be the first question asked for creating the tree. What should be the first question to be asked to construct a decision tree? One should ask the more important question first and the less important questions later. So step by step you can probe questions which are most important prior and less important questions further. So what is the most important question that should be asked to solve the problem? And here is the most importance of the questions determined. Thus how should the root node of the tree be determined? Determining the root node, in the example there are 4 choices based on the 4 variables. One could begin by asking one of the following: what is outlook, what is the temperature, what is the humidity, and what is the wind speed. Starting with the first variable, in this particular case it is outlook, it can take 3 values. What are those 3 values? First one is sunny, overcast, or rain. These are the 3 cases which can be taken with respect to outlook. Is that clear? Okay. Once we start with the outlook, start with the sunny value of outlook. There are 5 instances which are available in among the 14 instances. Outlook is sunny. In two of the 5 instances, the play decisions was yes, and in the other 3 decisions it was no. So thus, if the decision rule was outlook sunny, no, then 3 out of 5 decisions would be correct, while 2 out of 5 decisions would be incorrect. There are 2 errors out of 5. This can be recorded in row number 1, that is outlook sunny no 2 by 5. How did we get that 2? While 2 out of sunny decisions would be incorrect, hence there are 2 errors out of 5. that is in our first row. And coming to the second stage, that is or let us come to the second stage, that is outlook overcast S. So among all the instances you can check it would be S, hence there are 0 errors, 0 by 4. And coming to rainy, again it is 2 by 5, hence the overall errors is 4 by 14, that is 2 plus 2, 4 divided by 14 instances. Similarly, you have to construct you have to make rules for temperature. Hot, no, there you get 2 by 4. I request all of you to do step by step so that it will be clear for you. You can pause the video, then do one particular rules you can frame for outlook, then proceed for temperature, then humidity, windy, and so on. So here once you do this, now we get for outlook we got 4 out of 14, right? Similarly you have to do it for temperature, humidity, and wind. Once it is done, you draw a decision tree. Now our root node is outlook, next is in the left part is sunny, for sunny, and right side you can draw it for rainy. For sunny it is temperature, humidity, windy, and play. You can make the decisions. So what are all the temperature? So among this, for the first instance, outlook overcast, so the decision is yes. Similarly you have to do it for attribute temperature. So under temperature, next you have to do it for humidity, you have to proceed for windy. So under temperature, hot, no, that is 0 by 2, mild, no, 1 by 2, cool, S, 1 by 5. Here for humidity there are no errors, that is 0 by 5. Okay, and similarly here you have for windy 0 by 5. So finally when you construct a decision tree would come out like this. Outlook is our root node, outlook is equal to overcast. So coming to our problem, which we have here for problem solving, we have our outlook is sunny, outlook is sunny, temperature is hot, humidity is normal, and windy is true. And you need to make a play decision whether it is yes or no. So now, so outlook is equal to sunny. So now coming to sunny, you have humidity as 0. So humidity is towards your left side. Humidity, what is it mentioned? It is mentioned as high, 0, no, and normal, yes, because 2 comma 0, and windy, it is true, it is no. And that is how you need to make a decision tree. Hence, so the Vika classifier, this is a tool which is used for classifying the decision constructing a decision tree based on the training set which we provide. Okay, so if it is overcast, it would be S. If it is sunny and normal, it would be S, right? And if outlook is equal to sunny, humidity is equal to normal, it is true, right? So once we come to a conclusion, then we need to write the answer for the decision problem mentioned above. Now, looking at the constructed decision tree, you can come to a conclusion, and it is left to the students to write whether it is yes or no, looking at the constructed decision tree. Okay, so take a while, decide yourself based on the decision tree constructed, and try to answer the question. So next we would like to proceed with the next topic, that is on regression. So regression is a well-known statistical technique to model the predictive relationship between several independent variables, that is DV, and one dependent variable. So the objective is to find a best fitting curve for dependent variable in a multi-dimensional space, with each independent variable being a dimension. So here we draw a graph and try to solve the regression. So the curve could be a straight line or it could be a non-linear curve. So the quality of fit of the curve to the data can be measured by a coefficient of correlation R, which is the square root of the amount of variance explained by the curve. So the key steps for regression are very simple. So list all the variables available for making the model. Establish a dependent variable of interest, that is DV. Examine visual, if possible, relationships between variables of interest, and find a way to predict DV using the other variables. Correlations and relationships with respect to regression. So the first and foremost measure of strength of a relationship is correlation or correlation. Okay. The strength of correlation is quantitative measure that is measured in a normalized range between 0 to 1. A correlation of 1 indicates perfect relationship where the two variables are in a perfect synchronization. A correlation 0 indicates that there is no relationship between the variables. That is, if the value is 1, then the relationship is perfect. Else, the correlation, if the value is 0, then it indicates that there is no relationship between variables. The relationship can be positive or it can be inverse relationship. The variables may move together in the same direction or in the opposite direction. A good measure of correlation is correlation coefficient, which is the square root of correlation. So this coefficient is R can thus range from -1 to +1. An R value of 0 signifies no relationship. An R value of 1 shows perfect relationship. That is, if the R value is 0, it signifies no relationship. If it is 1, it shows perfect relationship in the same direction. Okay, so this is a Given two numeric variables x and y, the coefficient correlation is mathematically computed by the following formula: r equal to x minus x bar y minus y bar divided by square root of x minus x bar whole square or y minus y bar whole square. Okay. So here are few of the figures which are plotted in a graph. So coming to the explanation of each chart, chart A shows a very strong linear relationship, that is the value of y increases that means the value of y increases proportionally with the value of x. In the chart B shows strong linear relationship between x and y. Here it is an inverse relationship, that means the y value decreases with respect to y value. Is it clear? So similarly you can look at the chart C, D and E and F, which shows various relationship. So chart A and B are good candidates that model a simple linear regression model. The term regression model and regression equation can be interchangeably. Chart C too could be modeled with a little more complex quadratic regression equation. Chart D might require an even higher order polynomial regression equation to represent data. So here is an exercise which you can look into with respect to the cost of house price. Okay, so this you can work out as an assignment, or you can look into it later. So next is artificial neural network. So artificial neural networks, I hope all of you have gone through this particular topic as an elective subject in your previous semester. Just like it would be a brief introduction or a revision sort of thing. So artificial neural networks are inspired by the information passing model of a mind or brain. The human brain consists of billions of neurons that link with one another in an intricate pattern. So every neuron receives information from many other neurons, processes it, gets excited or not, and passes its state information to other neurons. So here we have several neurons, okay. And so artificial neural networks are very versatile systems. They are also used for classification, regression, clustering, association and optimizing activities. So artificial neural networks are used in finance, marketing, manufacturing operations, information systems, applications and so on. So artificial neural networks are composed of a large number of highly interconnected processing elements, those are called as neurons, working in a multi-layer structure that receive inputs, process the inputs and produce an output. An artificial neural network is designed for a specific application such as pattern recognition purpose, data classification and training through a learning process. So artificial neural networks are like black box trained into solving a particular type of problem, and they can develop high predictive powers. Their intermediate synaptic parameter values evolve as the system obtains feedback on its prediction, and thus artificial neural network learns from more training data. Okay. A few sample applications with respect to stock price. You can stock price prediction, where the rules of the game are extremely complicated and a lot of data needs to be processed, or very quickly processed in case of artificial neural networks. They are used for character recognition, as in recognizing handwritten text or damaged or mangled text. They are used in recognizing fingerprints. Right? So they are also used for fingerprint analysis. So artificial neural network is a multi-layer model, that is at least one input neuron, one output neuron, and at least one processing neurons is necessary. An artificial neural network with just this basic structure would be a simple single stage computational unit. The processing logic of each neuron may assign different weights to the various incoming input streams. So the processing logic may also use non-linear transformations, such as sigmoid function from the processed values. So more about artificial. In many practical situations, the predictions of artificial neural network trained over a long period of time with a large number of training data have begun to decisively become more accurate than human experts. A neural network can be is a series of which consists of a series of neurons that receive input from other neurons. They do a weighted summation function for all the inputs using different weights for each input. The weighted sum is transformed into an output value using transfer function. Learning in artificial neural network occurs when the various processing elements in the neuron. The transfer function of artificial neural networks is usually a non-linear sigmoid function, as told previously. If the normalized computed value is less than some value, say 0.5, then the output value will be 0. If the computed value is at the cutoff threshold, then the output value will be 1. It could be non-linear hyperbolic function in which the output is either -1 or 1. So the architecture ring a neural network. The most popular architecture is a feed forward multi-layered perception with back propagation learning algorithm, which are learned prior. So there are multiple layers of the system in the system, and the output of neurons are fed forward to the piece in the next layer, and the feedback on the prediction is fed back. So these are used especially for predictive data analytics also. Developing an artificial neural network. So these are the steps which are to be followed. So for this you need to have a good amount of training data, resources and skill. So gather the data, divide it into two types of data, that is training data and test data. The training data needs to be further divided into training data and validation data. Select the network architecture, whether it is feed forward or backward, and select the algorithm such as multi-layer perception. Set the network parameters. Next, fifth step is train the artificial neural network with training data. validate the model with validation data, freeze the weights and other parameters, test the trained network with test data. So the training an artificial neural network requires the training data be split into three parts, that is training data. The data is used to adjust the weights on the neural network, that is 60%. Validation data, the data is used to minimize overfitting of verifying accuracy of 20%. Testing data, which is used for testing purpose, final solution, which is around 20%. K-fold cross validation, that is also this approach means the data is divided into k equal pieces and the learning process is repeated k times, with each piece becoming a training set. This process leads to a less bias and more accuracy, but is more time consuming. This is about artificial neural network and regression. Next, one more important topic under classification, like we have cluster analysis. So what is a cluster? Cluster is nothing but a group of elements. So cluster analysis is used for automatic identification of natural grouping of things. So it is also known as the segmentation technique. So data instances that are similar to or near to are categorized into one particular cluster. So data instances which are similar and very near to each other are grouped together to form a cluster. Data instances that are very different as far away from each other are moved into different clusters. Clustering is an unsupervised learning technique as there is no output or dependent variable for which a right or wrong answer can be computed. The applications of cluster analysis: one is for market segmentation. You can categorize based on the market according to their similarities, for instance by common wants and needs and propensity to pay can help with target marketing. Product portfolio, you can use it for people of similar sizes can be grouped together to make small, medium and large sizes for clothing item. Text mining. So definition of a cluster: an operational definition of a cluster is that given a representation of n objects, find k group based on a measure of similarity such that objects within the same group are alike but the objects in the different groups are not alike. An ideal cluster can be defined as a set of points that is compact and isolated. In reality, a cluster is a subjective entity whose significance and interpretation requires domain knowledge. So how to represent clusters and classification, association, rule mining will continue in the next class. Hope all of you have followed few basic concepts of it and you can proceed with the same and you can repeat the video again and again. Your assignment is to construct a decision tree and try to solve a problem which was solved for regression analysis. So these two are your assignments. Hope all of you are staying safe at home. Stay back at home and stay safe. Get rid of COVID-19. Hope all of you are at your safer zones. Okay, thank you. And if any doubts are existing in the session, you can reach me out through my WhatsApp number, which is available with your CR, and try to solve the problem which is there in the for decision tree. And you can also uh, download few problems based on decision tree construction and try it on your own, so that you will become perfect, more and more perfect. Thank you.